Okay, so recall that the acceleration in the x direction is always 0.
Y is G.
AY is always G. Because the acceleration in the x direction is always 0, this is constant speed in the x direction. Oh. At the top of the path, AY is 0. If we're solving for final V, then you need final Vy and final Vx.
So basically, if they ask like what speed.
If they ask what speed right before it hits the ground or as it hits the ground, that's what
it.
you're looking for, yeah.
Okay.
Assumption 1, assumption 2, assumption 3, and assumption 4. Okay, so those are all the things I can think of.
So when they.
Oh, the last one is, if you're given theta and V naught, what can you calculate? It's like the first step in any of our projectile motion problems. You can do V naught x and V naught y.
Oh. Oh.
Okay? Okay, so let's do a problem. Before I give you the problem, Faith, I'm putting you on the spot here. Do you have your variables memorized?
Yeah.
Don't look at them. No cheating.
It's x initial. Well, you have your x and y. It's x initial, then y initial. Oh.
Okay.
Yeah.
Let's go. Do your work. Do
And
your
then x and y. And then isn't it x 0 naught or something like that?
V naught x.
Oh.
So the velocity initial and
And then with the y.
Then what?
And then isn't it like v of x and then v of y?
So initial, final. Good. What's next?
A of x and then a of y and then your time.
And then time, remember, goes for all of them. Because whatever the time is on the y side, it is on the x side as well.
I don't know why I said x0. I don't know what I was thinking.
And then from there, remember, you can fill in a couple of things.
Yo.
Okay.
I'm not looking.
You're doing fine. Oh, you know what? Let's do this. We're going to do an arrow. We're going to do a bow. Person with a bow. It's a bow. Just trust me. Decides to shoot an arrow. Okay. And over here, there's a cliff where the height of the cliff is 4 meters. Okay, so about 12 feet. Okay. He's standing on the ground.
Why is he mad with it?
He's concentrating. He's not mad.
Okay.
Okay, so he's on the ground. The height of the cliff is 4 meters. He's going to shoot his arrow at an initial speed of 14 meters per second with an angle of 60 degrees. Okay. The arrow flies and lands after 4 seconds. Where is the arrow? I just made 4 seconds up.
So we're finding the X.
Our goal is basically to figure out whether or not it hit the cliff. Okay, so we want to know, does it hit the cliff?
Would that be figuring out your X or no?
That would be figuring out your y. We know what y should be, but we want to figure out what y actually is after 4 seconds.
Okay.
Okay, so is arrow on cliff? Question mark? I don't write cliff problems for a reason. Okay, so let's fill in what we know. Before we fill in what we know, what can we do with what we've been given?
Components?
Components, right? So we can do
Yeah.
these two things, right? Okay, so let's do that. 14 times the cosine of 60 degrees. Don't forget to change your calculators.
I got 7 for VOX.
You have 7 for VOX.
Yeah, it's in degree mode, right?
Yeah.
Yep.
And then for VOY, I got 12.12.
Okay. And then for time, we have 4 seconds. Okay, so one of our goals is y, right? We want to see where it is as far as height after 4 seconds. So what formulas do you have in front of you that you could use to calculate y, given what we already have?
The fourth one. Y equals.
Y naught plus V naught YT. Yeah, I agree. So she chose y equals y naught plus V naught YT minus 1/2 GT squared. Did I say minus 1/2, right? Good. Okay, so we don't know y, so y is going to stay what it is. Four times 4 is 16. Times 4.9 is what?
78.4.
And then 12.12 times 4? 12 times 4 is 64, right?
So it's 48.48.
Total?
Yeah.
Whoa!
Oh, wait, I got that. It's
Okay.
48.48 for the 12.12
Okay.
times 4. Sorry.
Okay, so what did you get for y?
29.93.
Agree.
Because that should be a negative number, shouldn't it?
Negative 29.
Okay. 0.92? Okay. So what we're saying is after 4 seconds, the arrow is like way down here.
So it doesn't.
This is why I don't make problems up off the top of my head.
So it doesn't hit the cliff.
So, well, it like went beyond the cliff, right?
Yeah.
Right, like it went over or behind or down or whatever.
Yeah.
Okay, so now let's try to decide how long until it hits the cliff. At what time does the arrow hit the 4-meter cliff?
Is this where we make a new table?
Yep. So let's go back to this one real quick. What on here changes and what stays the same?
We don't know T.
We don't know T?
No.
Nope. Okay. Do we still know V naught Y and V naught X? Have those changed?
No.
No. Okay, do we still know why not?
Yeah.
Yeah. Do we know why? We do.
Wait, why? Okay. Oh, because it's 4 meters?
Mhm.
Oh, okay.
So right now what we're trying to analyze is how long does it take for it to travel that path?
Okay.
Okay. All right, so now we need time. Can we do it directly or do we have to do something else? Can we use the same formula?
Couldn't we, but we just have to do the quadratic equation?
Ah! You knew it was gonna happen.
I'm glad we're practicing this, like, doing the quadratic equation, right?
Yeah.
Okay.
Yeah,
So then here we're gonna get 4.
Mm.
Okay, so remember with the quadratic, I like to rearrange my quadratic equations to put the a positive. So I'm going to subtract everything from this side to get it over here with the 4.
And you said that helps, right? Like when
I
it's-
believe that it helps like plug numbers in when you're trying to do
and not
the
have a-
quadratic formula by hand. Like for a to be positive, it helps. Quadratic equation time.
Wait, question? If,
Yeah.
You know how it says like minus, like negative b?
Yeah.
And if it's like a negative in the equation,
So don't the negatives cancel?
okay, so that's how that works. I didn't know if you like didn't pay attention to the sign or not.
Yes,
So
of
it'd be
course.
positive. Okay.
So I'm gonna do it over here.
What do you get from your square root?
68.494.
Okay.
Okay, now this is where I get confused with where you're at right now. Like, how do you, with plus or minus, like?
So
you
I would
just
do it
two
twice.
of them?
Or so we're using t, aren't we? So it's t equals 2 possible answers.
Oh, and time can't be negative, so it's gotta be,
Whichever
One
one
of
comes
them.
out positive.
okay.
It's Tuesday.
Yes.
What is this?
We're practicing.
Okay, I don't know.
Ooh, they both come out positive.
But that one doesn't make sense.
Well, okay, so now let's think about the path, right? Right after it, if it starts at 0, isn't it gonna cross 4 meters twice? Because it's gonna go up and then it's gonna come back down.
Yeah.
So this is gonna be the first time point, and this is gonna be the second one.
So that's your correct one because it's hitting the.
Right.
It's hitting
Yeah, because after it went up, it came back down. So 2.08 seconds before it hits the cliff.
Did you just get the 8.28 by the square root?
Yeah, took the square root of 68.49.
Can I do it?
I slowly but surely removed numbers underneath the square root because it makes more sense to solve it one piece at a time.
Yeah. Wait, the 9.8. Yeah, I did that.
Where's the rest of the classmates?
Yeah, you could if you don't have questions.
Okay. All right, so that was our first question. Okay, so now let's do a new one. Do you agree with the answer?
Yes.
Do you understand why it's not the first answer, it's the second answer? Okay. So we're gonna leave all that. Now we know how long it takes before it lands on the cliff. All right, let's do at what speed does it hit the cliff as far as speed and direction?
Is that VY?
Hmm?
Are we solving for VY then?
So now let's go through our table real quick and let's identify the stuff we're gonna keep and the stuff we need to change. So first is y still gonna be 4 when it lands?
Yes.
Yes. Is t gonna be 2.08 when it lands?
Yes.
Yes. So that one we can keep. Do we have to change anything though?
No.
No. So in this particular case, we don't need to start all over.
How do you know when you have to start over?
You want to analyze the question, right? So for me, I said, how long does it take until we hit the cliff of our problem? Then I asked, at what speed? I'm looking for final information about the final vector. At what speed does the arrow hit the cliff? Okay. If I'm asking at what speed and direction does the arrow hit the cliff, what pieces of information do I need? I need Vx and Vy. Do I have one of those already?
Yeah.
Yep. So I just need Vy, right? So let's find an equation.
Oh, so this is like, okay, I get it now. Wait, no, I don't.
How many questions are going to be on this quiz?
I think it's like a total of 10. I don't even know if it's that many. Some of them are multiple choice, some of them are short answer. Just depends. Okay, so I'm going to use this guy to calculate Vy. What did you say? That sounds about right.
Yeah, I got that.
Should the number be negative? Yeah, because when we hit the cliff, the velocity vector is pointing downward. The x should be positive, and the y should be negative. Right? Okay. Okay. What's next?
Theta. Yeah.
These guys, right? Say again?
equals 10.83.
Is that meters per
Okay.
second?
Yep.
Okay.
That's her final speed. All right, and then what do you get for theta?
I got a negative.
Okay,
Wait,
that makes sense because it's below the.
yeah, I got negative 1.18.
Ooh.
I got negative 49.7. I got negative 0.
Oh, I didn't do tangent. I forgot the tangent.
Inverse tangent
Yeah.
of negative 8.26 over 7
in
Yeah.
degree.
in degree mode.
Yeah, well, I already had it in degree. I just forgot the tan.
Okay, so negative 8.26 divided by
I
7.
did get that.
I got negative 49.72.
Okay, wait, why is it positive? Do the square root again. The
Hold on.
8.26 part. And now negative.
So this one is negative? Is that what you're asking?
Yeah, like why is the first one positive and the
Oh, it's not, but when you square a negative number, the negative goes away. That's all.
Okay.
That's a good question. Okay, so that means we're below the horizontal at negative 49.72 degrees. What are some other questions I can ask you about this? What other types of questions have I had you solve using projectile motion
Can we
problems?
do the distance, like of
Could
X?
do range.
Yeah, the range.
Height.
Ooh, I like that.
Are you gonna give us the
What about height?
like the max height?
Max height. Let's do those two. Yes. If you want to see the formulas, they're up here. The formulas are ready to go. So you can start quizzing.
Oh, so you just did it.
Okay, so let's do another one. Let's say, how far away is the cliff? Okay. So looking at your formulas, what formula should we use? I guess here's the first question. Can we use information that we already have?
Mm-hmm.
Are we still analyzing the same problem that we were just analyzing? Yes.
Yeah.
So, what formula can we use for x?
X minus initial X plus VXT.
There's only one. I guess.
Yep. 3 plus 5, 6.
Okay. So there's my distance. That's one that I've solved for. This is one I've solved for. That's one I've solved for. Okay, next question. One more on this one. Let's find the max height.
So we don't know why.
Yeah, this one we started
Isn't the
why
H
is
equals?
why.
Hmm?
Is this something like we take off of the table because we don't have the same one?
Yeah, so is this a different problem than the one we were just looking at?
Yeah.
This is. So we're gonna start the table over. I'm just gonna erase it because my circles are getting out of hand.
Are you asking me for it? X initial, Y initial. X and Y. V naught X, V naught Y. V X, V Y. AX and AY, and then time. Thank you.
All right, what are the assumptions we can fill in?
The initials are
0,
Are the
negative g, v naught x and vx are the same.
So
Those are
7.
the three you can always fill in. Okay? Oh yeah, and then we already calculated what our initial information was given v naught and the angle. So are those going to be the same
Yeah.
for this? Yes, absolutely. So this one's going to be 12.12 and this one was 7. We solved that a little while ago. take my word for it. All right. Okay, so what do we know?
Our initials are 0.
Our initials are both 0. Good. What else do we know about this type of problem?
Oh, don't we know VY?
We do know VY. What is VY at the top of the path? 0. What's our goal?
Y.
Y. Do we have time? No. Do we have X? No.
Well,
All right.
Is X still that 14.56 number?
No, because 14.56 is how far the cliff is.
Oh, it's only 2 over the max height.
Mm-hmm. Okay, so let's find max Y. Okay, what formulas do we have in front of us? Are any of them going to be useful for us if we have Vy and V naught Y? That'll solve for Y final.
Third one.
Third one down?
Oh, we don't have T.
Oh, we don't have T. What's the one with the Vy squared? So Vy squared equals V naught Y squared minus 2G times Y minus 1 now. What is that, the fifth one down?
Yeah.
Those of you that struggle with identifying equations, did you see why that's the only one we can use?
Yeah.
Because it's the only one that doesn't have time. Right? And we don't have time at this point. Okay, so then we plug in what we know. That's 12.12 squared.
48.48.
No.
146.9.
What's 146.9 divided by 19.6?
7.49.
So there's the height of your projectile. Yes, ma'am?
Could you have used the height equation?
You could. Absolutely. Remember, I introduced these last for a reason. Okay?
You don't want us to?
You can only use them in very specific equations or only very specific situations. You can only use the height formula when you're trying to calculate maximum height, right? You cannot use it in any other situation. You can only use the range formula when you have initial and angle in order to get total x. Because x minus x naught is what we call range.
So, whenever they ask you for the max height, you can use the H.
You can use this one when they ask you for the max height, absolutely. Okay? Provided you have initial y.
Right.
Right? Okay.